think my talk actually builds up, quite unintentionally, but builds up really nicely on Gib's talk. And so Gib was asking the question about, how do you set a price for carbon, and how do we spend the revenues from that? And using the social cost of carbon as a way to, to determine what an appropriate price for carbon might be. I asked a different question, which is, we don't have a carbon policy in the U.S., and instead what we've got is a scattered mix of different renewable energy / low carbon policies. And so what I'm sort of going to talk about is what is the implied price of carbon when we look at these policies, and how effective are these policies going to be in actually achieving reductions in greenhouse gas emissions. So we've been, the last day and a half, we've been talking about, how there has been a very dramatic increase in renewable energy, both, globally. There's been a lot of increase in the U.S., wind and solar and so on. But really, as a share of our total fossil fuel, total energy consumption, this is still a very small percentage. And so we've looked at this graph, and so, less than 10% of our energy is really from renewable sources. A lot of that 10% is actually biomass, and a much smaller percentage is wind, and then an even smaller percentage is solar. And the projections are continue to be that a large amount of our energy consumption is going to be dependent on fossil fuels. Okay. So as a way to shift the needle towards more renewable energy, there have been a number of policies enacted in the U.S. And these have been, we haven't really had too many national policies. They have not had the focus of a carbon price, which as economists we would love to see. Instead, what we've had is these sector-specific policies. The two major sectors producing, heavily using energy, producing greenhouse gas emissions are electricity and transportation. And so the policies have been directed specifically at these two sectors. And many of these policies have been very regional. So California, of course, is way ahead of the other states in terms of, the low carbon cap and trade and other low carbon fuel policies. And then the other thing is that these policies have focused on technology. The technology forcing policies, setting standards for the share of different types of energy that we should be consuming. And then the fourth point about these is that they're very much focused on increasing supply of renewable energy, and not as much focus, especially on the fuel side, on increasing demand for renewable energy. So I wanted to put all of these things together and talk a little bit about what the implications of these policies are for the mix that we might expect if we were just looking at from a policy-driven incentive for a shift towards renewable energy, and at what cost are we likely to get these improvements. So, just a quick thing on the policies that I'm going to focus on. The Renewable Fuel Standard is one of the major policies that was established in 2007 to increase the mix of biofuels in our transportation fuel mix, and had set this very ambitious goal of 36 billion gallons of biofuels being blended with gasoline by 2022. Of course, we're way short of that target, but nevertheless, an ambitious policy at the time that it was set. The other policy that we've had, again with the 2030 focus, is the state renewable portfolio standards that sets, many of these are goals, but in some cases they are more binding mandates for the share of renewable energy that must be consumed in the state by 2025, 2030, and as you can sort of get a general sense from this, those targets vary dramatically across different states, with some of the states in the South not really having any particular targets. A third policy which we're sort of seeing coming on board, although not as fast as we would like, but is a Clean Power Plan, which has really been a very historic policy in the sense that it is one focused particularly on reducing greenhouse gas emissions from our electricity sector, and by 2030. Again, the targets set for that are state-specific. These are targets which are set initially in terms of the reduction goals for CO2 per megawatt hour to be generated by the states by 2030. Those targets vary quite a bit across states, ranging anything from about 11% to 54%. And there are various ways that these targets could be met. So states could either set a target on the rate of emissions that they want to reduce over this time period, or this could be converted into a somewhat of an equivalent quantity of emissions reduction, and they could try to say, well, we're going to reduce our emissions by so many tons between now and 2030. And there are still things to be decided, but there's a possibility that these states might be allowed to trade emissions among themselves as a way to achieve greater efficiencies in how they meet those targets. So the overall objective is that by the Clean Power Plan could in fact reduce emissions by about 32% by 2030 relative to the level in 2005, and you can sort of see the different pathways they might take, and they roughly come out to about 32% by 2030, which is about 20%. Actually, if you look at it, the reduction, some of the reduction would be happening anyway between now and 2020 or so, but so there's about a 20% additional reduction by 2030 compared to what would have been otherwise. So we've done an analysis looking at, if these policies were to be implemented as they were planned, ignoring for the moment all the other hurdles, and if the technologies for them were available at levels that are at the cost that are being projected by the DOE and the National Renewable Energy Lab and so on, what could we achieve? What could we expect in terms of the share of renewables in the economy in the U.S. by 2030? And so this is sort of an estimate of what you might expect from the current level, which is about 9-10%. Since we don't look at everything that's there, but about say 9% or so. Currently, how would these policies actually lead to an increase in the share of renewable generation by 2030? And so you can sort of see that the renewable portfolio standard, if it were to be implemented as stated by the various states, would get to about 16% or so. The Clean Power Plan would be much more dramatic. I mean, it could actually get to the 20 to 25% by 25, but 20 to 24% or so, by 2030, it still means that 75% of our fuel would be coming from fossil fuels. That's in the electricity sector. In the transportation sector, if we were to achieve the renewable fuel standard, which was very questionable, then you could get about 24% of the share of our transportation fuel being from biofuels. Okay. What would that do to greenhouse gas emissions from the electricity sector and the transportation sector? So the RPS and the RFS would actually, despite their goals, would really only reduce emissions by 5 to 6%, in 2030 relative to what they would have been otherwise. The other policies, as we've said, would get it down, compared to business as usual in 2030, would get it down to about 20 to 25% or so. So really, in order to see the large reductions, you need a policy like the Clean Power Plan or something even more ambitious if we want to get significant reductions in these emissions. And it has to be focused. It has to be a climate-focused policy rather than a renewable energy-focused policy alone. Okay. Now, just sort of looking at the technology for a moment, the technology itself, which in particular looking at, in the case of transportation fuels, is promising. So if we look at, alternatives for reducing, or alternatives for producing biofuels that are more advanced than the corn ethanol that we're consuming currently, there's significant potential to lower the greenhouse gas intensity of transportation fuel if we in fact could get to these advanced biofuels, particularly those produced from perennial energy crops. And so crops like miscanthus, a lot of research being done at the University of Illinois on that, switchgrass, in fact are negative carbon fuels because they have such a tremendous potential to sequester carbon in the soil that they can become sinks for carbon rather than being emitters, and so you could potentially see large reductions in greenhouse gas emissions with those. And so the analysis which I showed, where you have this 5% reduction despite having 16 billion gallons of these types of biofuels, is because despite the fact that you have these, there's also a lot of other types of biofuels. So you have biofuels from corn stover, there's a mix of fuels, not all of which are equally low in terms of their carbon intensity. And so the overall reduction in greenhouse gas emissions is much more modest than you might expect when you look at particular types of biofuels that might form the mix of that. And so really looking at the trajectory that one might expect, even with an increase of 16 billion gallons of the most advanced types of biofuels that we're talking about here, you'd get to the 6% or so reduction, if we look at this over a 2022 time frame. And if we really gave the large subsidies to advanced biofuels and could shift away from corn ethanol all the way to advanced biofuels, you could double that to about 12% by 2022. So now, even, despite the fact that our reductions are, with the Clean Power Plan, you get about a 20-25% reduction, the question is, what is the implied price of carbon? So we talked about the social cost of carbon, which really tells us what the monetary value of the damages due to climate change or due to carbon emissions are. And as you pointed out, that's varies depending on when you're looking at it. But if you look at the graph that you've shown, in 2030, if you assume the 3% discount rate, the price of carbon, the social cost of carbon is about $50. And so the implied price of carbon, if we, based on